Hi guys, I am going to do an example problem today for projectile motion, but really it's just going to be an object in free fall. Okay, let's take a look at our problem and you'll see why. So this problem is a cannonball has been dropped off of a cliff that is 50 meters tall. Since it's just being dropped, there really is only motion in one direction. That's in the y direction, right? So if I've got my cannonball, it's being dropped off the cliff, it's just going to move down, right? There's no horizontal displacement. So it is a projectile, but really it's just an object in free fall, which means that the only acceleration it's experiencing and the only force it's experiencing is gravity. Okay, so just a little motion map to get us started. I know it starts from rest, and then I know it's going to get gradually faster in speed until it reaches the ground. How much faster? Well, gravity, right? So first thing, let's write what we know. Our acceleration in the y direction is g, gravity, which I'm going to say is 9.81 meters per second squared, okay? And I'm going to choose this to be a positive value today because I can do that because I'm going to say moving down is in the positive direction today. Easy. Don't have to deal with a bunch of negatives. I'm also going to say that the top of the cliff here, that's y equals 0. So that means my y final is going to be 50 meters because going down is positive, so that's the positive direction. So that means that my delta y is 50 meters minus 0 meters. So I can say that my delta y is a positive 50 meters, okay? Just to make sure that all my negatives work out, I don't get a negative time or something like that. Cool. What else do we know? We know that our initial velocity in the y direction is 0 meters per second, and that's all we need to know. So we need to pick an equation that's going to work for us. I've got my list in front of me, and I'm going to pick this one. Delta y equals v naught y t plus 1/2 a y t squared. And remember, I'm including all the y's because now that we have to think about two directions, I need to make sure that I'm only thinking about the velocity in that direction, the acceleration in that direction, the displacement in that direction. Don't want to mix things up. Okay, I am looking for time. Okay, so let's plug in our zeros first. So since velocity initial in the y direction is 0, I can cancel this out. And let's rewrite it. Delta y equals 1/2. I know my acceleration of the y direction is g, so I'll just replace it with a g. T squared. I want to get t by itself. I'll multiply both sides by 2. So now my 1/2 cancels. And then I'm also going to divide away g on both sides. And that cancels. Let's rewrite this. T squared is equal to 2 delta y divided by g. But I don't want t squared, I want t. So I'm going to square root both sides. And it's going to be t equals the square root of 2 delta y divided by g. Now we can plug in values. So square root of 2, our delta y is 50 meters. Divided by g, that's 9.81. If I plug that in my calculator, I'm going to get time is equal to 3.19 seconds. Great. We're done with that problem. Let's take a look at the next one. What is the cannonball's velocity just before it hits the ground? When I say just before it hits the ground, I mean like, what's this velocity, right? Not when it hits the ground, right? Because then it's just a 0. That's boring. So we want to know right before it hits that ground. Let's write what we know. I know that velocity initial in the y direction is 0. I know my acceleration in the y direction is g. I know my t is 3.19 seconds. I know my delta y is 50 meters. So much information. I can solve for basically whatever I want, right? So we are looking for velocity final. Well, we need an equation with velocity final and some of this information. I'm going to pretend that I don't actually know that time yet, so I didn't have to solve the problems in this order. So let's use the equation velocity final squared equals velocity initial squared plus 2a delta y. And this is all in the y direction. Let's plug in our zeros. Now that's 0. We know that our acceleration is going to be g, so let's rewrite this. Velocity final in the y direction squared equals 2g delta y. I don't want velocity final squared, I want velocity, so I need to square root both sides. So velocity final in the y direction is the square root of 2g delta y. Now we can plug in our values. 2, 9.81, 50. See, this is why it was important that we thought about what direction was going to be positive, because I don't want to have a square root of a negative value, because that's going to give us an imaginary number, and we don't like those. We're not dealing with them. So I plug this into the calculator, and I'm going to get a velocity final in the y direction of 31.32 meters per second. And that's it. We're done. Hope this has been helpful.